experiment itself states that when a magnet is moved close or away from wire, right? Or if the wire is moved closer away from the magnet, or if wire is moved close or away from magnet. In both cases, what happens? In both cases, okay, in both cases, the galvanometer, the needle of the galvanometer, the galvanometer needle fluctuates. So like we said in the experiment, when the magnet is brought close to the wire or the wire is brought close to the magnet, the magnetic interaction of the magnetic field of the magnet and the current carrying wire will induce electricity on the wire. Hence the galvanometer needle is going to fluctuate because electricity has been induced. Okay? So this means that electromagnetic induction now. This is EM induction. Hence, what has happened? Okay? Electricity or as we say, electric current is induced on the wire, is induced on the wire due to interaction of magnets, magnetic field, the magnetic field of the magnet, and with the magnetic field of the current wire. This is the idea of electromagnetism. So electromagnetism is saying that when interaction of magnetic fields between a magnet and a current carrying wire will induce a current, okay? So in this case, what happened was when we brought the magnet close to the wire or we brought the wire close to the magnet, the galvanometer started to fluctuate, it started to show a reading. This reading was a sign that current was induced on this wire. So in both cases, electricity or electric current is induced on the wire due to interaction of magnetic fields between the magnet's magnetic field and the magnetic field of the current carrying wire. Perfect. Now, let's understand why this happened. Okay, let's go in depth to the electrons. Let's go here. Why and how this happens. Okay, So we know interacting magnetic fields of the magnet and the wire will produce a current. But how is the current produced exactly, okay? What is actually happening inside the structures to produce this current? What's happening to the electrons? How are the electrons being forced to flow? Because electricity is flow of electrons. How does interacting magnetic fields even cause the electrons to flow? Let's have a look at that, okay? Now we're going to, again, to explain this, I will do a rough drawing first. With the rough drawing, once we understand the rough drawing, we're going to go to the detailed explanation where we will write it all to understand. So right now, let's stick to the rough drawing. In the rough drawing, please be with me over here. We have a conductor, okay? This is conductor wire. This is a conductor wire, okay? Now, number one, what do we know about a conductor wire? Any electrical conductor has free, mobile, delocalized electrons spread throughout the conductor, correct? So, any conductor has free, mobile, delocalized electrons spread in it. Perfect. Any single conductor carrying wire has what? It has a magnetic field around it. Any wire has a magnetic field around it, which is from the wire itself, correct? So, this is magnetic field of what? Of wire. Perfect. And these are what? These are the free mobile delocalized electrons. Free mobile delocalized electrons. Perfect. So this is the conductor wire. A conductor wire, as we know it, we have the free mobile delocalized electrons to move any current, carry charge. We have a magnetic field around the wire, and we have a conductor wire. Now, what will happen if I bring a focus here? If I bring a magnet, if I bring a magnet close towards this wire, towards wire. This now, what we did over here, when we brought the magnet close to the wire, we said a current was induced. Now we are zooming into the wire. We are going inside the wire to understand how current was induced. Okay? Look at this part carefully. The magnet itself, okay? The magnet itself, magnet has a magnetic field. We said interaction of magnetic fields between the magnet and the wire produce electricity. So the magnetic field of the magnet is always from north to south, correct? This is the magnetic field of the magnet, right? And then over here we have the magnetic field of the current carrying wire. This is the magnetic field. As you can see that as I am bringing the magnet close to the conductor wire, there is interaction of the magnetic field of the magnet and the conductor wire. This is the interaction point. This right here. Interaction between magnet and conductor's magnetic field. Okay? What's going to happen when two magnetic fields interact? A magnetic force is produced. Because if I have two magnets over here, a north and a south magnet, if I bring them apart close to each other, they will attract each other because of the interaction of the magnetic fields of opposite polarity. If I have two north and north, they will repel each other because of the interaction of the magnetic field of like polarity. The same way, whenever two magnetic fields interact, a magnetic force is there. The same way, when the magnetic field of the magnet interacts this point of interaction with the magnetic field of the current carrying wire, it will produce a force. And this force that is produced will push the electrons to flow. Now this force, magnetic force produced, and this magnetic force will push the electrons to flow. Push electrons to flow, creating a current. So this exactly is how electromagnetic induction takes place. Again, from the beginning, what is happening in electromagnetic induction? We have a magnet, okay? The magnet has a magnetic field around it. We have a current carrying wire. Conductor always has electrons inside it, and it has a magnetic field around it. Any single current wire has a magnetic field around it. There is interaction between the magnetic field of the magnet and the magnetic field of the current carrying wire. Due to this interaction, a magnetic force is created, because two magnetic fields, when they interact, they create a magnetic force. This magnetic force is so strong, it will push these electrons, push the electrons to flow more, and this flow of electrons creates electricity, inducing or creating a current. And this is why there was a reading on the galvanometer. So what has happened here is explained here in detail. Magnet brought close to the wire. Wire and magnet interaction of magnetic fields. Magnetic force created. Magnetic force pushes these free electrons to flow faster, creating a current. Perfect. This is the idea, okay? Now I'm just going to click a quick picture of this board, and then we are going to draw the same idea in a small area, and we're going to write everything we have explained about this idea.